Bhaskar Rao, founder CEO at Technosphere, where we are into developing connected devices, IoT solutions. My previous background in security has been I was heading the India operations of a smart card and RFID security company, making electronic passports and DoD for security devices, etc. E-health. Thank you. I think the what Phil mentioned about the scale is mind-boggling compared to where what we have today in terms of computers, the number of devices, the number of areas. For example, we may have a some sensor sitting in a ship, sense or some control logic for a pump control through the IoT network. So the whole landscape is very wide, and therefore the threats are also in that much potentials are there. Of course, since we also not talking about internet on one side where data is flowing or from sensors to the cloud and back, and maybe to other servers when for analytics purpose, etc. on one side. The other side of thing is the sensors themselves are wireless. Okay, so there is another new element in the potential for attack right at the sensor to gateway. So some spoofing, some denial of service attacks, etc. can also happen at the low level. So right in a local area network, wireless network, is also vulnerable. So the vulnerability is everywhere. Of course, if we see the kind of attacks which have happened so far, I would agree with Phil that they are all pretty straightforward attacks. Like some baby health monitoring or heart beat monitoring device did not have a proper password, security or a password, and therefore the password could be easily snooped and collected. Another place, there was, it was running like a hotspot without a security, a wireless network operating without security for another healthcare application. So these are basically, I think the implementations have been very raw initially, and this also have come from the fact that at the device level, the amount of space available in memory or the power for battery life which we target, etc. They actually are contradictory to adding so much of security features and implementing a lot of algorithms and making the device secure. So this is the contradictions. We have to find ways to really manage these attacks for that. Okay, I think some of these standards have emerged for really secure applications, like common criteria for smart cards on one side, NIST security for certain key transactions and so on. So I think we there are guidelines for how do we write software for such applications. For example, in common criteria, when we were doing smart card readers and RFID readers, the pin pad reader, it will be verified by auditor whether this code is having any vulnerability, that the last pin which was pressed by the user is cleared before the next transaction. So there is a certain guidelines for development, and there is a validation or certification for implementing such a security. So I think these concepts need to be moving into the IoT domain in order to provide our software. What we write is also that level of security. That I think is what we can do. Then if you take the world already, if you take aerospace, if you take railways, they already implement what is called safety integrity levels. So, and they don't go and overboard and say for everything there is a highest level of security. It depends on the particular, if it's a lighting or a fan in or AC in aircraft, there's a different level of security software integrity level we check. Whereas if it is something which is it results in fatality, that's a higher level of safety level. So these are categorized, and there are software tools available from many companies, where our code can be put in. Of course, they are not simple microcontrollers, a little more high level of some RTOS, etc. With that, you can actually evaluate with this tool that how secure is our code, or how what are the vulnerabilities possible, what are the like code paths which are not okay, there are no error paths are not validated. So all of that is tested, and these are the vulnerabilities finally which will come out. A hacker can see, yes, this error path is and not covered, so he can get in there in his code when he wants to do that. That is on software security. Then there is also an element of in an embedded device. When we talk about the end device, there is a code which is residing there, right? So how do we protect that code? How do we ensure that nobody can come and write a new code altogether? And of course there is other aspects of it, that is we'll talk about other encryption part. But the key is that we want to be able to update the security levels, because it's an emerging thing. So we want to be able to add some new security features maybe to the code on one side. And then at the same time, we don't want somebody to update the software with something else, and the device is doing something else. So this is the trade-off. And again, using our technologies like TPM, we can implement safe software, which is difficult to hack. We will talk about it a little more on hardware. Thanks. I think the definitely there is a lot of work to be done. In case of a breach, what are the response and other actions. But however, I think we can try to prevent. That is what there are technologies or options available today to improve the security level, and make sure that our devices are as secure. To give you an example, our cell phones have SIM, right? So fairly secure. So although there's a keys, private keys, which are stored, same keys are stored in two places, one with our cell operator and one with us. And till today, it's not been easy that people have hacked that. So that technology is being moved into, when we talk about connected device level security, so that the keys and the whole authentication process between the end application and the connected device is happening in that level of a security. That means the smart card, which is the chip which is there in the phones, etc. Same technology is being brought into the connected device, where along with the microcontroller we can attach a small device. They come with various levels of security. Again, some just just hashing algorithm, some with AES, some with the TPM. So this way, when we connect a microcontroller and this device, and then we have a secure way of provisioning and registering these, pairing these devices, these secure chips, then we have end-to-end security. That means three important aspects are there in security. One is authentication. That means we want to make sure that yes, the right guy is there. So, and we know passwords are shaky, they can be spoofed, they can be sniffed, they can be picked up from somewhere. So therefore, instead of the password, the keys which are stored securely in these devices. In fact, I think he talked about even X-ray, or any other way of there are other attacks like electrical voltage attacks, etc., by which we can maybe pick up from a normal memory storage of data or a key. But these smart card or these chips which are secure chips which are coming out, they have actually also made in the fabrication itself, they have made it a complex that a hacker cannot read in the code which is secure, key which is present. So authentication is important. Then there is confidentiality. That means we don't want the data transaction which is happening to be viewed by someone, because today he may view it and use it in some other context, right? So therefore privacy issues are also there. So confidentiality means we need to provide some encryption. Data has to be put it encoded in a manner that it cannot be hacked or picked up in the transit. Then most importantly, integrity. This is what causes the actual havoc in IoT. If in case the integrity is compromised and we're not detecting it, then we can have a boiler which is overflowing, or we can have some entire smart city clogged and jammed. Okay, so therefore the integrity of the data validation is important. That means whatever is receiving, that integrity is also maintained. So these are all going to be available today once we have this smart chips. A couple of semiconductor vendors already announced, and they are all available for fairly reasonably priced also. So that's the way I think, at a device level security will come. And this, what we talked about, trusted platform, is also a standard from the trusted computing group, and therefore there's some X.015 some standard already in place, so that end to end security for devices is possible. I think especially at the embedded, at the end level, the power is an important factor for doing any software updates, because the battery life is, maybe it will supposed to last for 3 years or 2 years, based on maybe sending 10 bytes of data every hour or every 12 hours. And with the moment we say, we want to update the firmware in the device, so maybe the entire battery life will be gone. So this is another aspect to be considered.
Great.
Yes.
So thanks. I think our time is up. Before
Thank
you could throw us out,
so,
I
no,
close this.
I'll just make sure the lunch has to start.
Okay. So thanks everybody, and thanks all of you. Thank you very much.
Take a photo.